Assalamu alaikum. In this lecture, we will see that how in normal approximation to the binomial distribution, whereas the normal distribution is a continuous distribution and uh, binomial distribution is a discrete distribution for the large values of n. And why we are taking it only for the large values? Because when the n is large, the binomial probability distribution takes the symmetrical shape. So there are 2 points mentioned in the slide. The first one is relevant to the types of distribution and the large values of n. And the second point, the normal probability distribution is generally a good approximation to the binomial. In which condition? When n probability of x, sorry, n into the probability of success and n into the probability of failure are both greater than 5. So these are two conditions for normal approximation to binomial. Moving on to the next slide where we will see a graphical illustration for the larger n values. So here we can see that when n is 1, n is 3 and n is 20. So when n is 20, the shape of distribution is becoming symmetrical and closer to the normal distribution. So let's move on to the next slide. So here is the continuity correction factor. So the continuity correction factor is basically used for the normal distribution approximation to binomial because discrete distribution have a exact values, but in continuous probability distribution there are intervals. So if x is equal to 0, so the continuity factor will be minus 0.5 is less than equal to x is less than equal to 1.5, sorry, positive 5, positive 0.5. We are doing this for when x is equal to 0. In the next case, if we have a x is equal to 1, which will be 0.5 less than equal to x is less than equal to 1.5. So this is called a continuity factor, which is converting these values into interval. So we are subtracting or adding 0.5 depending on the problem to a selected value when a binomial distribution is being approximated by a continuous probability distribution. So let's move on to the next slide. These are only 4 cases may arises when we do the approximation in the case of binomial. So for the probability at least x occurs, use the area above x. In this case, we will subtract 0.5 from x. In the next case, for the probability that more than x occurs, so in this case, we will use area above, or we will add the continuity factor into the x value. For the probability that x or fewer occur, use the area below x, add into continuity factor. For the probability that fewer than x occur, use the area below x, subtract the continuity factor. So these are 4 cases that may arise when we are handling the situation. So let's move on to the next slide, which is the example of normal approximation to binomial. Suppose the management of the Santoni Pizza restaurant found the 70% of its new customer return for another meal. So X is the success that new customers return for another meal for a week in which 80 new first time customer dined at Santoni. So what is the probability that 60 or more will return for another meal? So here we are going to find the chance that there will be 60 or more customer will return to the Santoni Pizza for dine. Let's see what is the procedure of normal approximation to binomial distribution. So the given data is relevant to the binomial distribution, and at a very first stage, we will find out the probability of X by using binomial distribution. So here is the combination formula, then the probability of success, then the probability of failure. We will multiply these three uh, expressions, then we will get the probability, and we will find out these values for 60 to 61 and so on. So we are going to finding the X values greater than equal to 60, and then we will find out the cumulative probability distribution. So let's move on to the next slide. After getting the probability, we will do the, we will follow these two steps to find, to do the normal approximation to binomial. The first one is find the mean and the variance of binomial distribution and find the z corresponding to an x of 59.5. So here you can see that we are using the correction factor. We are subtracting the 0.5 from the x value, which was 60%. We have used the binomial formula for mean calculation and standard deviation calculation. And after that, we put the value where we use the continuity factor it at the place of x, and then we use the mean and the standard deviations value which were calculated from binomial distribution, and then we will find out the z value, which is equal to 0.8. So after finding out the value of z score, we are going to see the corresponding table value of this score, which will be 0.3023, and the total area of 1/2 is 0.5. If we subtract this value from 3023, which will be equal to 0.1977. So we are going to find out the area from 59.5 and it's beyond. So this is the area beyond the 59.5. So the probability is 0.1977 that 60 or more out of 60 will return to the Santonis. So this is the normal approximation to the binomial. So let's have a recap of the procedure. So first we need to find out the probability by using binomial distribution. Then we need to find out the mean and standard deviations value. And after that, we will use the continuity factor in a z-score and then find out z value. And after that, whatever the case is given, we will follow the instructions. So thank you so much. Here is the end of chapter 7. We will move on towards our next chapter, which is chapter 8. Assalamu alaikum. Now we are moving towards the chapter 8, which is relevant to sampling methods and the central limit theorem. So before starting this chapter, let's have a brief review of chapters we have covered in this semester. So from chapter 2 to 4, we learned that how to describe the data and also the computation of statistical measures, which includes the measure of central tendency and the measure of dispersion. In chapter 5, we starts to lay the foundation for the probability concepts. In chapters 6 and 7, where we have discussed the probability distribution for continuous random variable and discrete random variable. And now this is chapter 8. Then we are going to understand that what is sample and what are the methods to take sample from a population and what is the central limit theorem. So let's move on to the next slide. Sample is basically part of population which represents the population and uh, give us some inference from the population. So these are the learning objectives we have for this chapter. So we are going to explain why a sample is only feasible way to learn about a population. So describing the method of select a population, then the construction and the sampling distribution of a sample mean. Then we will see that how the central limit theorem work and what is the use of central limit theorem to find the probability of selecting possible sample mean from the specified population. So let's move on to the next slide, which includes why sample the population, that why we need to take sample from a population. So the first point shows that to contact the whole population would be time consuming. So it is very time consuming and costly to reach out for each and every item or a respondent of the population and collect the data. So the third point is basically the physical impossibility of checking all the item in a population. So it means that the physical impossibility, if a firm is producing items on at economy of scale. Economy of scale means that in a production in a bulk, so it is not possible to test each and every item. Then for this purpose, we will use sampling method and we will select a sample from the population and find out that how many items or how and what percent of items are faulty in a given sample. The destructive nature of some tests. So the destructive nature of some tests include that uh, sometimes you cannot take the samples of each and every item. So there are some kind of tests we can use for sampling. So let's move on. So fifth point is the sample results are adequate. So let's move on to the next slide. I think these points are quite self-explanatory, that if you read these points, you will easily understand that why sample the population. So let's move on to the next slide. Probability sampling. Probability sampling is sample selected such that each item or a person in a population being studied has a known likelihood of being included in the sample. So it means that A selected item or a person in a population is being studied. So each and every item or a person in a population has a equal chance to be being selected in a sample. So the probability sampling basically is the, if you can remember that in binomial probability distribution, we have a uh, we are doing a trial for a dice. If we roll a dice, we will get 6 possible outcome, but we know very well that each outcome have a equal chance to be occur. So this is the probability sampling. Now there are some most commonly used commonly used probability sampling methods. So four are named here: simple random sampling, systematic random sampling, stratified random sampling, and cluster random sampling. So we are going to discuss these sampling methods one by one. So let's have a look on simple random sampling. A sample selected so that each item or a person in the population has the same chance of being included. So this is very well-known kind of procedure. It's normally, it's also followed by some lottery drawing kind of procedure, that we put the uh, slips of paper in a hat and just mix them up all, and then we draw a slip from that hat and we announce the winner. So this is that kind of sampling method. So here is the example. A population consists of 845 employees of a Nitra Industries. A sample of 52 employees is to be selected from the population. The same number is the name of each employee is written on a small slip of paper and deposited all of the slips in a box. After they have thoroughly mixed, the first selection is made by drawing slip out of box without looking at it. So this process is repeated until the sample of 52 employees is chosen. So in this given information, so they are going to select a sample of 52 employees, but the population is 845. So they will draw 52 slips randomly without looking at them. So this procedure is called the simple random sampling. So let's move on to the next slide. So the simple random sampling can be use the table of random numbers such as the one in appendix B6. A table is given at the end of the book in appendix B6, so they can use these numbers for this purpose. These are the unique numbers for each and every employee, but they can also use the identification number of an employee, because identification number is also a unique number. So each and every person is allotted a unique number as their identification number. So let's move on to the next slide. The systematic random sampling. So the systematic random sampling is use the K formula. K formula is population size divided by sample size. If I can say that a colony have a 36 houses and this is the population, 36 houses, and I want to select 6 houses from that population. So I will divide 36 divided by 6, which will going to equal 6. So I am going to select every sixth house from these 66 um, houses. So let's see the example from the book. A population consists of 845 employees, a sample of 52 employees. So the first they are going to calculate the K as a population. So this is the K formula. Population size divided by the sample size. For Nitra Industries, we would select every 16th employee. So where did they get this 16 from? It is actually the division of population and sample size. If k is not whole number, then round it down. So sometimes we have a like this number. If we divide these two numbers, the answer will be in a decimal form. So they just round up the number and use it as a k. Okay, random sampling is used is in the selection of the first name, then every 16th name of the list thereafter. So this is the same example as I mentioned here, that every sixth house is going to be selected in a sample. Moving on to the next slide. So here we have a stratified random sampling. A population is first divided into subgroup called strata. So in this method, we are going to segregate the population in different groups, or you can say in subgroups, where we can do that on the basis of age, uh, gender, or it can be income level. So whatever the requirement of the sample. A population is the first divided into subgroup called strata. So these subgroups are called strata, and a sample is selected from each stratum. So these are the terminologies you need to understand, that these groups are called strata and a sample is selected from each stratum. Useful when a population can be clearly divided into groups based on some characteristics. So that particular random sampling type is used when the population characteristics are clearly defined. So let's move on to the example. Suppose we want to study the advertising expenditure for 352 largest companies in the United States to determine whether the firm with high return on equity, a measure of profitability, spent more of each sale dollar on advertising than firm with low return on deficit. So there are stratums given 1 to 5, and then profitability. So the level of return on equity is also given, and the number of firms are list here based on their return on equity. So this is a particular characteristics which considered in this sampling procedure. Then we have found the relative frequency and the number of sampled. To make sure that sample is a fair representation of 352 companies, The companies are grouped in a percent return on equity, and the sample proportional to the relative size of the group is randomly selected. So the procedure is also given here. Moving on to the next slide. The fourth type of sampling is the cluster sampling. So the cluster sampling, the population is divided into clusters using naturally occurring geographics or other boundaries. So this sampling type is used for the population which is geocentric. Then clusters are randomly selected and the sample is collected by randomly selecting from each cluster. So clusters are randomly selected and sample is collected by randomly selecting from each cluster. So first they are this sampling technique is considered the geocentric, and then those clusters are randomly selected, then they will going to follow the simple random sampling, and for sample they are also use the same techniques for technique for the random selection. Suppose you want to determine the views of resident in Oregon about the state and federal environmental protection policies. Cluster sampling can be used subdividing the state into small units. Either countries or regions, select a random, say 4 regions, then take the sample of resident in each of these regions and interview them. Note this is the combination of cluster sampling and a simple random sampling. So as we have discussed here that this sampling technique is basically the combination of cluster sampling and the simple random sampling. So if we can say that this is the state having 12 clusters, subgroups, and they are going to select only 4 regions, these colored regions, and they will collect the data uh, from their residents, the resident, based on randomly selecting method. So here at the cluster sampling, we have done today's lecture here. So in next lecture, we will discuss the central limit theorem. Thank you so much. Allah Hafiz.